conducting experiment test entitled Field Density Test by Sand Cone Placement Method. And for our materials, we're going to be using seed sand, a trowel, sand coat, a big scrape, a digging bar, a sand container, a metal tray, a steel stick meter, a weighing scale, and a soil dry oven.
Weigh the metal tray, sand cone, and sand container.
So now we're going to fill the sand container with sand.
So since our sand container is not yet full, we need to get some sieved sand in the drying oven.
Now we're done filling up the sand container with sand. So now we're going to weigh the sand container with the sand cone together.
We will now calibrate the sand container and the sand cone with the sand inside by inverting it onto the base plate. Once the sand stops moving here, we will now measure the sand remaining inside the sand container.
Now let's bring together the sand container and the sand cone.
After weighing this, we should repeat this procedure for trials 2 and 3.
What? Ay, go.
Pwede na mo na ikuan ba?
Ayaw mo, ayaw mo yun sa iso.
So after the weighing, all the weighing, place the base plate on the top of the chosen location. So here, and dig 15 centimeter deep into the soil.
Iya din niya si Ma'am Amal.
I-weigh dahil dito?
After digging the hole of 15 centimeters deep, we will now fill the hole with sand.
So now we're going to the drying oven to dry this soil that we just dug up from a 15 centimeter deep hole. So but before putting it inside the drying oven, we're going to weigh the soil sample. So currently, we are now walking towards the triple beam balance to weigh this sand container with the remaining sand and sand cone.
thus conclude our experiment for today.
It is now already 24 hours. We will now get our soil from the drying oven.
So after the soil has cooled down, we will now weigh the sample.
The field density test was conducted following ASTM D1556 or D1156M24, which is the standard method for determining soil density using the sand cone method, which helped compute the volume of the excavated hole, which is 1,876.38 centimeter cube. During testing, moisture content was determined using ASTM D2216-219, which involves drying the soil sample in an oven for 24 hours at 110 plus minus 5 degrees Celsius. This process ensured accurate moisture readings which directly affect soil compaction. In addition, ASTM D4254-216 was referenced for evaluating the soil's relative density and compaction characteristics. For soils containing oversized particles, adjustments were made following ASTM D4718M215-2023 to correct the unit weight and water content calculations. Several challenges affected the test accuracy, including sand spillage, uneven ground, and maintaining the integrity of the hole during excavation. External factors like wind and soil consistency also contributed to potential errors. To ensure reliable results, a material engineer must properly calibrate the sand cone, carefully excavate the hole, and account for moisture adjustments, especially in soils with oversized particles. This test is essential in construction, ensuring that soils meets compaction standards for supporting roads, buildings, and embankments. Proper soil density prevents structural failures, and if results indicate insufficient compaction, further soil treatment may be required. Following ASTM standards ensures accurate and consistent testing, making this procedure crucial for engineering quality control.